Oftentimes, we want to store files and images in a database and then later retrieve them for end users to see or download these files. In this video, we will use Spring Boot to create a new project, including dependencies to enable us to easily read and write to our database. We will create the model, service, and controller layers. We will implement the view layer using Thymeleaf. So at the end of this video, we should be able to provide a simple interface to our end users to upload files to our database and then download these files from the database too. Alright, let's get started. I have Spring Tool Suite running on my machine, which is a flavor of Eclipse. Let's click File, New, Other, and then from under Spring Boot, let's choose Spring Starter Project. Let's give the name to our project as Blob Demo. We will use Maven. Let's include the Spring Boot DevTools. It is optional and it helps in the development process by not having to restart our application to see our changes. Let's include Spring Data JPA, Spring Web, and Thymeleaf. Click Finish. For this demo, we will use the H2 database, a lightweight open source Java database. Let's open the pom.xml file and include the H2 dependency, which will let Spring Boot auto-configure this database for us with just a few properties. Let's now open the application.properties file. H2 has a web console. Let's enable it by setting spring.h2.console.enabled property to true. Let's specify the Spring Data Source URI, which is a file-based database pointing to the dev-db file. Let's put the database driver class name as org.h2.driver. Now for the simplicity of the demo, we will let JPA auto-create the tables for us upon startup. So let's put the spring.jpa.hibernate.ddl.auto to create. Let's customize the server port as 8777. Now for the file upload, let's specify the spring.servlet.multipart.enable to true. Let's specify the multi-part file size threshold as 2 kilobytes. Let's set the multi-part max file size as 200 megabytes. Set the max request size also to 200 megabytes. You can adjust these values to suit the file size you want to allow to upload. Alright, now let's create our database table to hold the files. Here is our main class. So right-click on the project, choose New Package, call it Model. Now right-click and choose New Class and call it Doc. Let's annotate it as an entity to work with JPA. With the Add Table annotation, let's name the database table as Docs. Let's fix the imports. First, let's create the primary key with the add ID notation. Let's have it generated automatically for us using the add generated value with strategy as generation type.identity. This ID column will be of type integer with the name ID. Let's create a string variable to hold the document name, another to hold its type. With the @LOB or large object notation, we define the byte array with the name data. Fix the imports. Let's create a noargs constructor. Right-click and choose Generate constructor using fields. Select everything except ID as it will be auto-generated for us. Right-click and choose Source, Generate getters and setters. Select all and generate. Alright, now let's create a package for the repository by right-clicking and choosing New, Package and calling it Repository. Right-click on the package, choose New, Interface and call it Doc Repository. Click Finish. Let's extend it with the JPA repository working on object doc, which has an integer ID. Let's fix the import. And Spring JPA will do the heavy lifting for us, creating the correct methods for us without us even writing a single line of code. Next, let's create this service package by right-clicking and choosing New, Package and calling it Service. Let's create a new class by right-clicking and choosing New, Class and calling it doc storage service. Click Finish. Let's give it the add service annotation. Let's autowire our doc repository. Fix the imports. Let's first create a method to save the multi-part file passed to the database. We get the document name by calling file.getOriginalFileName. Let me create a try-catch block. Let's create a new document instance by using the constructor passing in the document name, document type as file.getContentType, and the data as file.getBytes. Let's now save the document to the table by calling docRepository.save, passing in the doc, and then return the resulting doc. Fix the import. If there is an exception, we will return null. Now, let's create a method which returns the document. Method name is getFile, which takes in the integer ID of the document we want to retrieve. Let's return docRepository.findById, passing in the file ID. To account for the case for file not found, we make the return document optional. To get all files, we can create a method which returns a list of documents called getFiles, which returns docRepository.findAll. The repository makes it so easy for us to implement the database CRUD functionality. Now, let's create the controller package by right-clicking and choosing New Package and calling it Controller. Let's create a new class by right-clicking and choosing New Class, call it DocController. Let's mark it with the add controller annotation. Let's autowire the doc storage service. Fix the imports. Let's create a get mapping to the root URL. The method returns a string, which is the name of the ThymeLeaf template to display, and takes the model as the input parameter. We get a list of documents calling the doc storage service.getFiles method. Add it to the model as an attribute with the name docs. Then we return the name of the ThymeLeaf template, doc, which we will create soon. Let's fix the imports. Next, let's create a post mapping for URL upload files. The method returns a string and takes in the request parameter, which is an array of multi-part files. Inside, we loop over the multi-part files and call the doc storage service.savefile method to save it to the database. Then we return redirect : sending it back to the root URL to display the documents in the main page. Next, we create a get mapping of download / specifying the file ID requested. The method will return a response entity of resource. We name it download file. We get the path variable in an integer variable file ID. Inside, we get the document by calling doc storage service.getFile, passing in the file ID. Let's fix the imports. We return response entity.ok, specify the content type as mediatype.parseMediaType, getting it from doc.getDocType. We add to the response header content disposition as attachment with the file name as doc.getDocumentName, and then in the body we send a new byte array resource of doc.getData. Let's fix the name. Let's change the return value to response entity of byte array resource. That is it. Now let's create our ThymeLeaf template. ThymeLeaf expects the templates in the source main resources templates folder. Right click there and choose new web HTML file. Call it doc.html, the same name we are returning in our controller. Let's add the ThymeLeaf namespace. Change the title. In the body, let's create a div to upload multiple files. Let's create a form with ID upload files, name upload files, method post, and action as ThymeLeaf's th action as add curly braces, and then /upload files. Note the ThymeLeaf syntax. We specify the encoding type as multi-part form data. Next, we create input type as file, name as files, the same name our controller is expecting. If you want multiple files upload functionality, put multiple. Otherwise, don't put multiple if you just want a single file upload. Make it required. Next, let's create a submit button. Now, let's create a div to display and download uploaded files. Let's create a table, table head element of ID, name, download link. Next, let's create the table body. Using timeleaves th each, we iterate over the documents returned back as using $docs model attribute, taking in each iteration the document in the doc variable. Then inside td, using th:text, we get the document ID as $doc.id. Note the syntax. Doc.docName for the document name. For the download link, we create a th:/href element specifying the download link as curly brace /download file / and then add the doc.id as the path variable. Close the curly brace. Display download. That is it. We have the page ready. We have already tied it to the H2 database in our application.properties. Oh, let me fix the casing of the driver name. Good. Let's run our app. Right click, choose Run as Spring Boot App. It starts on port 8777. Let's go to the browser and go to localhost :8777/h2-console to see our H2 database. The JDBC URL is the JDBC URL from our application.properties file pointing to our file-based DB. SA is the default username, no password required. Click Connect. Here we see our docs table auto-created. Let's run select star from docs. There are no rows currently. Next, let's look at our website. Here is our page. Let's click the Browse button. Let me pick a Word document, a PDF document, and an Excel file to show variety. Click Submit. And they are uploaded. The redirect brings back to the page, refreshing the document lists from the database. Here are the download links. Going to H2 database console, if we run the query again, we see our documents, the document name, etc. Let's click Download on the doc to get it from the database. Let's open it. I am on Ubuntu Linux and so it will open it with LibreOffice. Opens just fine. Download the PDF and open it. Download the Excel and open it. Cool. So we were able to successfully upload and download documents to our database. In this video, we created a Spring MVC project using Spring Data JPA to upload and download documents to a backend H2 database. We created a Thymeleaf page to demonstrate the upload and download functionality. Thanks for watching.